Greetings and welcome to Lesson 3, Cyber and the Collection Phase in INTL 644, Cyber and the Intelligence Cycle. If any lesson within the course could be labeled a core lesson, it would have to be Lesson 3. Because Lesson 3 gives us the opportunity to really explore how the cyber domain is different from, and in some cases complements, the traditional domains. We will be able to apply the intelligence cycle of cyber operations by knowing how the collection phase differs. We will look at some of the challenges created from the cyber domain. We will differentiate cyber versus traditional. And unlike any previous lesson, we will spend some time on legal and policy challenges, in particular, how the president himself, through presidential decision directives, can impact directly the cyber business. As I mentioned in previous lessons, virtually any conflict in the future will be a joint one. Joint implies more than one services. And as a practical matter, it will be combined and joint, combined meaning several nations. I've listed the principles of joint intelligence from the Joint Pub on this slide. But let me digress and emphasize that there are some practicalities that are not addressed, particularly in the combined environment. Each country has their own national priorities and issues. Each country's military personnel serve a military boss from their service. The individual's career rests on the opinion of their national military boss, not how well they execute the combined mission. In NATO headquarters, for example, positions are assigned often by quota of rank and country. In some cases, the individuals in the slots are not experienced in the field, not in most cases, but in some, and there are the inevitable personality clashes, particularly at the senior ranks, the lieutenant colonel and colonel, 0405, commander and captain in the Navy rank, because those individuals are trying very hard to impress their admirals or generals. I'll give you a minute to look these over. The one that suits the cyber environment the most is the third one from the bottom, agility. Flexibility and adapting to the changing situations are critical. Cyber, as we've discussed, knows no borders. Consequently, there has to be a recognition for cross-border issues and cross-border cooperation. Individuals and organizations working in a joint environment need to build trust and work very much as a team. Interpersonal relationships are very, very important, as is the need for networks where individuals can go to other sources, either within their nation or within allies of that nation, to find the resources needed to help accomplish the mission. Intelligence sharing across national boundaries is sometimes difficult. Conceptually, you can look at the United States and our relationship with other countries as sort of an onion. The countries that the United States has had historically close relationships with include Canada, Britain, and Australia, as well as New Zealand. The United States has also worked on many levels with France and Germany in the post-World War II era. Planning is important, but when you have a multinational team, not every nation's workforce is going to work at the same tempo. Consequently, you need to consider that if you're working in a multinational environment and need to get input from different national groups. The complementary operations would go back to what are the strengths of that particular national force, and how does that national force contribute to the overall picture. One area that is important is linguistics and the ability to translate languages that are perhaps not very common and not studied very broadly. And so nations that have native speakers of some of these less popular languages can be an important piece in the combined joint intelligence puzzle. The cyber domain represents significant differences from the traditional domains, partially because it spans not only the physical world, but logical, meaning the software as a service, and so on, as well as human resources. We'll talk a little bit about how organizations try and get situational awareness of their cybersecurity a little bit later on in this lesson. But I think it's fair to say that due to the depth and breadth of the cyber battlefield, not to mention the op-tempo, situational awareness in the cyber side is difficult. Next to last bullet on this slide, the work products may have to be modular. In developing intelligence work products, you would be well served by thinking about the kinds of customers. For those of you who have not handled U.S. defense materials before, there are, of course, the caveats, top secret, secret, confidential. But there are also attachments, or I don't exactly know what the right word is, modifiers that are sometimes applied. So you could have a document that is secret no foreign. No foreign spelled N-O, F like Fox, O-R-N. No foreign means it's not releasable to foreign nationals. There are also varieties of restrictions to nations where you might have releasable to Canada, UK, and Australia only, and so on. The point is that this is a challenge in the cyber domain, and advancing technologies can exacerbate this challenge. This is looking at some conventional intelligence approaches in the cyber battle space. Open source intelligence, human intelligence, and computer network exploitation are three boxes I have on the chart. HUMINT can be particularly effective and needed, actually, against cyber targets. Insiders are particularly good sources. Chelsea Bradley and Snowden come to mind. But as we'll talk about in a bit, the complex nature of today's networks and software make probing and understanding what kind of hardware-software combination the target has critical to determining collection and attack possibilities. I didn't mention covert operations. But we can think of covert operations here under the rubric of computer network exploitation, CNE. And in the last lesson, we talked about advanced persistence attacks and other kinds of malware that can be used in a covert manner. You can do, as many movies have, use a human agent to go into a physical computer location, a server room, with the ability to transmit from inside, in theory undetected, or the ability to somehow plant malware, malicious software, that will help the attacker or the analyst understand what the environment looks like. If we look at some traditional intelligence collection techniques, image intelligence, signals intelligence, and cyber intelligence added on. Signals intelligence, technical monitoring can be certainly appropriate and relevant and necessary for national security. However, technical monitoring may not be admissible as evidence because both the federal rule, U.S. federal rules of evidence, and individual states have guidance on when data can be admitted. The personal environment is fair game. The mobile phones of significant individuals, great target, and with the growth of the Internet of Things, whereby devices like your refrigerator and your car are connected to the Internet, this opens up other possibilities, particularly with respect to automobiles. A key point I want to make with respect to SIGINT and the cyber world is that in the history of SIGINT, alliances were made often to get access to targets that were prohibited by geography. So the U.S. wanted to have countries like Turkey that were situated close to the old Soviet Union, for example. Given the borderless and porous nature of the Internet, alliances are still important, but maybe not for geographical purposes. With respect to image intelligence, everyone has a cell phone, and everyone has become, in some ways, an image collector. The cell phone cameras get better and better, and they tend to be easy to use and can store quite a bit of photos. The second thing is the democratization of satellite imagery. Google Earth, as an example, has made satellite imagery with pretty good resolution available to anyone who wants to buy it. Some of the others, measuring in signals intelligence, geographic, are relevant here. Open source probably being the most important, as I mentioned earlier. But what about cyber intelligence? What are the components of cyber intelligence? Well, at this point, cyber intelligence is a relatively nascent field, and there is no real agreement on what are elements of cyber intelligence, but I think you'd agree that these three pieces are ways to collect cyber intelligence. Penetration testing means using technological and social methods to try and gain unauthorized access to a target computer system. Computer network exploitation means burrowing into a target computer, as the Chinese have done, trying to learn whatever it is you can. Social media intelligence is the technique of using Facebook and Pinterest and Twitter to learn more about individuals, processes, perceptions, and so on. I can give you one example. In a conference I went to in Washington, D.C., the speaker spent 2 hours, and I'll save you the 2 hours. The speaker basically said, by watching the volume of tweets and the nature of the tweets, we can tell how the public is perceiving a disaster. And the tweets follow pretty much a bell curve. There's a run up till the peak of the disaster, and then there's a run down and trail off as the effects of the disaster trail off themselves. Social media intelligence is also freely accessible and worthwhile understanding how that works. Turning our attention to vulnerability exploitation, what the heck does this mean? Well, the first step is to inventory the hardware and software of the target. You also inventory the versions of the hardware and the software. Organizations that are well managed from an IT perspective have a very, very disciplined patch management program. This means that they recognize there's a defect in the software, the vendor has come up with a fix, and they implement those patches or fixes. However, the implementation of patches is not as simple as it may seem, because today's code is just so complex that it's often hard hard to determine what the effects will be of putting in a patch. But when you have the list of vulnerabilities, there are lots of places out on the internet where you can find attacks that have already proven themselves successful against those product flaws. And you can buy those for a relatively inexpensive, comparative to the gain, price. Here are a couple of vendors you might want to check out. For those of you who are not familiar with the acronym COTS, it stands for Commercial Off-the-Shelf Software, in this case. Commercial Off-the-Shelf, COTS. As I mentioned, enterprises, large organizations, have thousands and thousands of users all over the world. They also, like the government, are subjected to cyber attacks frequently. And they want to have a picture of what does their cyber security status look like. And so they employ Security Information and Event Management Systems, SIEMs. You can check out my reference here to get a good basic tutorial, but suffice it to say there are several vendors out there that provide these products across enterprises. It's also important to point out that the vendors are moving from software as a product you buy to a service you subscribe to, which is where the market is going. Whether the government will go that way too remains to be seen. Lastly, we're going to look at legal issues. And I'd like to spend a few moments on Presidential Policy Directive 41, which President Obama published in July of 2016. Notice that there are two classes of incident. The second one uses the phrase demonstrable harm to the national security interests, etc. And I think it's important to point out that there are incidents every day. There are lots and lots of incidents, hundreds, thousands of incidents across large networks. The challenge is to concentrate on those incidents that present the biggest risk to the organization and that need to be followed up quickly to mitigate the harm. In Roman numeral 3 of PPD 41, The President outlines 5 principles guiding incident response. And as a practical matter, I think these 5 principles could be equally applied to the commercial sector. One is that there's shared responsibility. Individuals, the private sector, government agencies, etc., all have a piece of this. The second is that it should be risk-based response, so that the greater the risk and potential harm, the greater the resources applied. The third principle is respecting affected entities, recognizing that there are privacy and civil liberty issues, and that entities may have sensitive, private, commercial information. Fourth point, unity of government effort, state, local, territory, tribal. The governments have to work together synergistically, notwithstanding jurisdictional issues. And the last point, enabling restoration and recovery. The name of the game is to recover from the incident as quickly as possible. There are some other laws that govern particular industries. Graham-Leach-Bliley governs financial services, for example. Sarbanes-Oxley talks about the integrity of business records of publicly held corporations and requires a certain degree of compliance. The technology issue, one of them, is what came to light with the San Bernardino terrorists, where the vendor, Apple, did not want to cooperate with the FBI. As it turns out, the FBI was able to pay somebody else to unlock the phone. It's not clear whether NSA has the capability to unlock the phone, but the fact of the matter is you need to be sensitive that there is this tug of war where the vendor, Apple, wants to protect their product because their buyers trust their product to be secure, even from the government. There is quite a patchwork of privacy laws throughout the United States, and I've given you a reference on this slide. The fact is that states agree that certain information is sensitive and must be protected. Personal health information, acronym PHI, and personally identifiable information, acronym PII. That's the information that would allow someone to steal your identity. Name, address, phone number, etc. So, privacy laws are critical in the cyber domain. They haven't been much of an issue in the traditional domains. I've got 2 interesting questions for this week. Hopefully generate some controversy. The first one is, do we need millennials to do cyber intelligence and social media intelligence? Because the long-standing analysts are just not clever enough at Facebook and LinkedIn and Twitter to do it. And the second one is focused on vendors, and do they have a duty to help the government by building in less security into their products, even though it's not in their own best interest. Next week, lesson 4, we're going to take a look at processing and analysis. We'll focus quite a bit on big data and metadata, and we will look at functional and strategic analysis. And hopefully you found this to be an interesting lesson, and I look forward to next week.